Hi everybody and welcome to today's live. My name is Pallavi and I am doing this live on behalf of 11 Plus Journey, which as you all know is this great group where parents and tutors can connect with each other and learn more about the 11 Plus and each other's experiences. So I'm just waiting for this to go live on my side and right, okay, looks like we're all here and ready to go. So today I'm going to be going through the topic of algebra. Before I go into any introductions, I think it's a good place to start by going through what are the contents of today's live and also who this live is aimed at. So today we're going to be having a look, we're going to be going through these 7 key content points. We're going to do a brief welcome and then we're going to have a look at the 11 plus and algebra. What is algebra and what are the rules of the game? And then covering briefly 2 key topics in algebra, simplifying expressions and solving equations, before ending on a nice Q&A. In terms of who this topic of algebra is aimed at, I would say that parts 1, 2 and 7 are more for parents, and 3, 4, 5 and 6 are a resource for children, in particular those children who have just finished year 5, about to go into year 6 and do the 11 plus exams later on this year. So in particular children who have never come across algebra before and want to brush up on the fundamentals and basics, and this is a resource for them. In addition to this live, I also have created a 5-page PDF, and this is really a document for those children who like to learn a little bit more visually by looking at a resource in front of them. So the link to this PDF document is actually in the description, and it looks a little bit like this. You don't necessarily need it for today's live, but it is a resource that children can use afterwards. Okay. And so I'm almost ready to start off with the welcome and then go into the 11 plus and algebra. Before I do that, I think it's important to mention that when it comes to the work I'm doing today, especially with points 1, 2 and 7, a lot of this is based on my own opinion and my own experiences with the 11 plus and with algebra. As we all know, with the 11 plus, there's no real blueprint and exact step-by-step guide to preparing and also for passing the exam. However, I hope that with the information that we covered today, that there's something there for everybody to be able to learn and pick up from. And for those who might need to do their own research based on their own schools and examining boards and exams that they are going for, then they are able to do that as well. So when it comes to my experience with 11 plus, so I'll just briefly touch on that. I run a company called Potential, and we started off at the beginning of lockdown when schools closed. I wanted to do something for children so they kept learning, and so I started teaching maths for free from my Facebook page, Maths with Potential. And through that, I was creating resources and then set up a website where parents could purchase educational maths resources and also tests as well. And prior, my potential was all aimed at children who are between the ages of 7 to 11. So a lot of my students go for the 11 plus. And prior to setting up my Potential, I'd set up and ran 2 tuition centres around London where my students were going for the South West Hearts Consortium schools, Slough, Tiffin Boys and Girls School, and also Bucks. And I got a chance to connect with Saba, who runs this amazing group, along with her team of admin. And I've always found this a really great resource and a place for parents to come together and also meet tutors from the wider 11 plus community and just bounce ideas off each other, learn from each other's experiences, and also provide each other with great free resources like what we are doing today. So I think that covers my introduction, and I think we are ready to talk about the 11 plus and algebra, which is point 2 on my itinerary here. So one of the hot topics that I found comes up a lot in this group is around why hasn't my child learned algebra yet? Or is algebra definitely going to be on the 11 plus exam? Now, the truth is, when it comes to will it come up on the exam, yes or no, nobody really knows the answer to that. the best that anyone can do is prepare themselves for it. And some children might not have experienced learning the 11 plus if they haven't reached year 6 yet. I know that schools do cover it in year 6. Some might cover it in year 5, but when I've been teaching students, a lot of them seem to have not covered it yet, so they usually learn it first through me. And so when it comes to preparing for 11 plus, it's helpful to have a foundational understanding of algebra, which is what we are going to cover today. So to cover that point off, no one can predict what comes up on the test paper. There are different examining boards. You've got the GL assessment, CEM, a lot of practice material that is done in the style of these examining boards. Sometimes has 11 plus algebra questions on there. So it's a topic that students do learn to help better prepare them. So when it comes to what is algebra, so let's now get into the foundations. So algebra essentially is when we look at numbers in place of, when we look at letters in place of numbers. So let's say you have something like x. X is actually known, the correct term for that is a variable, right? And it's a letter that represents a number. It doesn't have to be X, it can be any letter of the alphabet, but we tend to see X being used quite a lot in questions. So with X being a variable that represents a number, a question is going to either tell us to solve what X is by giving us some information, or tell us to do something with X, again with providing us more information. And when it comes to algebra, two topics that you may have come across already are expressions and equations. Okay, expressions and equations. Now, let's first of all think about, well, what do both of these things have in common with each other? Well, expressions and equations can involve letters, and it can involve numbers, and it also can involve operating symbols like plus and minus. But the key difference between an expression and an equation is the equal sign. You see, an expression does not contain an equal sign, whereas an equation does. And it's really important to remember that little fact there, because depending on whether you are dealing with an expression or an equation within a question, the question will be completely different. So it's important to have an understanding of that key difference. So let's have a look at an example of both of these. So an example of an expression can be something like 2x plus 3. Okay, 2x plus 3. And if we looked at an equation and we considered at the equal sign, an example of the equation can again be x plus 7 is equal to 14. Now, if you are not sure what we mean by 2x plus 3 and what we mean by having an equal sign and what that means, that's totally fine, because you haven't learnt the rules of the game yet. So algebra, just like any other topic in maths, you need to learn the nuances and the way things interact with each other to be able to answer these types of questions. And what I will say, what some good news is that when you get your head around a few tips and tricks that I'm going to go through today, everything becomes a lot more easier. And that's because algebra has a lot of similarities with arithmetic. Where we add, subtract, multiply and divide in arithmetic, we also do that a lot in algebra. But the difference is, because we are dealing with these letters, these variables that represent numbers, we have to understand how these variables interact with each other and what are the things we can do and the things that we can't do when it comes to using the 4 operations with algebra. So let's have a look at that. As I mentioned earlier, X is quite a popular letter, so that's the one that I'm going to use now. I have X here. Unless the question tells me any more information, I can't really do anything with this. But what I can do is I can understand more about what X is on the face of it. Now, X does not have a number in front of it, but we can all see there is one X here. So just know that there is a 1 there in front of it, even though we don't usually write that in questions. The other thing that is there that we cannot see is the power. there is actually a 1 here. But again, we don't usually write it. If there's a 1 as a power, we just leave it as we do, as it is. And I bring that up because when we start to add different algebra terms together, it's really important to have an understanding of what the number is in front of it and also what the power is. So here you have 1x, right? And here you have 2x, and then you can have 3x, 50x, 100x, and so on. Now, if I wanted to add this x with 2x, if we think about arithmetic, 1 plus 2 gives you 3. So 1x plus 2 lots of x is going to give me 3x, right? Now, there are certain conditions that allowed me to do that. And they revolve around what I just mentioned earlier about the number that was in front of x and also the power of x. So x plus 2x, let's just revisit that. The two conditions are as follows. So whether there are numbers in front of x, that doesn't really matter. What matters is that when you have the same variable, so they're both x, and the same power, then you have two like terms, okay? So like terms are the same variable, meaning x. So if that was a y there, then they wouldn't be like terms, they'd be unlike terms, and the same powers. Those are the two conditions. And why that's important is because I need to have the same power and the same variable in order to add or subtract algebra terms like this. So that was how I was able to do x plus 2x, which gives me 3x. If I had something, I'd mentioned before y, but let's say if I had x squared plus 2x, the answer wouldn't be 3x because there's something completely different going on here. So you would just leave it as it is. So something that I did there, which if you guys have been following, you might have just learned how to add like terms together, but what you've also learned is how to simplify expressions. Because as I'd mentioned before, x plus 2x with no equal sign is an expression. So if a question asked me to simplify my expression, what it's essentially saying is group like terms together. What are the conditions for like terms? Same variable, same power. Does it matter if they have different numbers in front? No, it doesn't. Like terms are same variable, same power. So if it asks me to simplify this expression, all I have to do is think, okay, well, x, I've got 1x here, 2x here. So to simplify it, my answer would be 3x, right? Let's do something a little bit more trickier. What if I had, I don't know, 10x plus 5x plus 2? Okay, well now I've got a 2 on the end here. To simplify this, I've got something where I've got the same variable here, and they both got the same power, so that can easily be 15x. But 2 on the end, I can't add that 2 to 15 because, go back to what makes them like terms, 2 does not have a variable attached to it. It's actually known as a constant at the end. So because of that, I just leave it as plus 2, okay? And just very quickly, I'll just do a minus example as well. Let's say you have, I don't know, 8x minus 6x minus 2. Again, we have a minus 2 on the end, so 8x minus 6x gives us 2x, and then we carry the minus 2 here, and that's the expression simplified. And you will have obviously come across simplification, maybe when you've done either ratios or when you've done fractions in particular, so you know that when we are simplifying, you might be going from something that looks quite big to something that looks quite small, but the values of both of them are the same. Okay, the values don't change, it's just we are almost tidying it up together by grouping these like terms together. Cool. All right, so what have you guys learned so far? You've learned what x represents. It represents a number. You've learned about like terms. You've learned about how we can add and subtract algebra expressions together and terms together. And then you've also learned a little bit about doing the same with if you were using different numbers and you were also doing the same as if you were looking at expressions that had different variables. You know that you can't do anything there because they're not like terms. So now I think what we can do is we can have a look at when we are looking at expressions and brackets are involved. So let's say I have 2x plus 1, right? And you might know from your own work within maths that brackets are almost the first thing that you think about when you start to see them in anything. So again, there's no equal sign. We know there's an expression there. So we're asked to simplify it or expand the brackets. Now to do that, we have this number right on the outside of the brackets. And what that's saying is essentially saying it's giving us an idea of multiplication. So when we want to do this, we first of all multiply with the first part of the brackets, and then multiply with the second part of the brackets, and remember our operating symbol at the end. So 2 multiplied by x is actually 2x. So how we'd seen that before, when we see a number that is right next to a variable, it's actually a multiplication. So 2 multiplied by x gives us 2x. Let's think about our operating symbol of addition. And then 2 multiplied by 1 gives us 2. So that's how we expand the brackets, and we follow these 2 steps to do that. So it becomes 2x plus 2. Okay? Cool. Now let's have a look at equations. So I mentioned before that equations involve an equal sign. If I have something like x minus 5 is equal to 10, that equal sign is saying whatever is happening on this side is the same value as what is happening on that side. Now, for those of you who are quick with your arithmetic, you might look at that and say, okay, well, that's pretty easy. I can easily see that actually x is equal to 15 because 15 minus 5 gives me 10. Boom, done. And that's great. When you're dealing with much more complicated numbers, or let's say if you've been given something like 3x plus 7 equals 12, you can go the long way and start just inputting numbers into x or trying to figure it out. But once when you know some of these rules around equations, you can do it in half, if not the quarter amount of time. So let's go back. Got x minus 5 is equal to 10. Okay, so fight that urge to put 15 as x straight away. And let's have a look at what is going on here. So equations are all about balance, like I said before. Whatever happening on this side is also happening on that side. What is the goal when it comes to equations? To solve x, to get into a format of x is equal to a number, right? To do that, you have to isolate x. You have to get this x on its own. And because you have this equal sign, you have free rein to start moving things around that equal sign so that x becomes on its own. But you have to follow a few maths rules first. And that is, if you remember that whatever happens on both sides of that equal sign is all got to be in balance, just know that whatever you do on this side has to also be done on that side. So if I wanted to isolate x, a good way to start would be to get rid of this minus 5, right? And get it in that format of x is equal to something. So to get rid of minus 5, well, what can I do to minus 5 to get rid of it completely? Well, I can plus 5. If I was to plus 5 here, I'll be left with 0, and that's brilliant. I don't have to worry about that anymore. But if I'm going to plus 5 on this side, I've also got a plus 5 on that side, right? So I always like to just put plus 5 both sides there. So if you plus 5 on this side, you get something like x minus 5, which is this bit here, plus 5 is equal to 10 plus 5. Plus 5 on both sides. Let's tidy that all up. X minus 5 plus 5 gives us 0, so it becomes x is equal to 15. Okay? Let's have a look at another example. Why don't we have a look instead, and feel free, if you've got a pen and paper in front of you, feel free to have a go yourself. Let's look at something a little bit more challenging. Let's do 2x plus 3 is equal to 15. 2x plus 3 is equal to 15. I'm going to go extra slow, so if any of you do want to try and work this out yourself, feel free to have a go. Remember your rules. It's an equation. Two things are balancing. We've got two sides of the equal sign. They're both balancing with each other. Whatever happens on one side happens on the other, okay? So I've got 2x plus 3 is equal to 15. I want to eventually get it in the format of x is equal to something. First thing I might want to do is get rid of this 3. okay? How do I get rid of it? Well, it's a plus 3 here, plus 3. So if I have 3 and I'm minus 3, well, then that gets rid of my plus 3. If I'm going to minus 3 on this side, I've got a minus 3 on that side. Let's just do that. Yeah, minus 3. So I've got 2x plus 3. Hope you guys can see this. And if you can't see my board, just let me know. I'll always just move closer to the camera. So you've got minus 3 here is equal to 15 minus 3. Let's tidy that up. I have 2x is equal to 12. Okay, I'm getting closer. I'm not quite there yet. It's not in that x equals something format to help me solve it. So what can I do? So I have here 2 multiplied by x. Remember, when you have a number that's right next to a variable of x or any other letter, it's that number multiplied by that letter. So there is a multiplication going on here. So like I was doing up here, I was doing the opposite, wasn't I? To getting rid of the 3, I did plus 3, but then I got rid of it by doing minus 3 on both sides. So what will I need to do? Well, if there's a multiplication going on here, to get rid of it, if I divide it by 2 on both sides, then that will help me get rid of this 2 and get it into format of x is equal to something. So let's do it. I've got divided by 2, divided by 2. Remember, it's got to be on both sides. X is equal to 6. Let's see how you guys did. Brilliant. Okay, I'm seeing some comments come through. Fantastic. All right, so yeah, that's correct. I can see a lot of you have commented x is equal to 6, so well done. So now let's just do another quick recap. We've had a go at learning about the rules of the game. These are some of the very basic rules. There are other ones as well, which I could go through in a later video, but it is all available on that 5-page document. And then we've had a look at simplifying expressions. And we know that when we're simplifying expressions, we're not changing the value of it, we're just making it smaller. We're grouping these like terms together. And then we've had a look at solving equations and why we want to solve equations. What's that goal? To get it in the format of x is equal to something. I think what I'm going to do is I'm going to go through one more thing, because this also comes up in equations, and it's this whole notion of substitution. So this is when you are given a bit more information and you might see 2 different variables come up. So let's say if I've got something like x plus a is equal to 5. Okay, really simple. X plus a is equal to 5. But the question says, solve x if a is equal to 3. Solve x if a is equal to 3. So I've been given this information. Without that, I would just be stuck. I wouldn't really know what to do. I would just leave it as x plus a is equal to 5. But because I've got that, I can substitute a equals 3 into this part here, and then build an equation around it. So x plus 3 is equal to 5, and suddenly that becomes a much more easier equation for me to solve. I can find x, I subtract 3 on both sides, x is equal to 2. Yeah, and then if you have time, let's say if you're just doing this for practice to begin with, and you have time to double check your answer, you can substitute both x is equal to 2 and a is equal to 3 back in here. I have 2 plus 3, and we know that 2 plus 3 is equal to 5. Okay, cool. All right, so we've covered quite a lot. If you guys have a look on the PDF, you can do this after this live now, then you will see I think it's about six or 7 questions on there, which you can have a go in your own time. I've also got a Q&A ready as well as part of the last part of our live. So if you have any questions, start firing them over. And I can see a lot of you from the comments had a go at these questions. So I can't see any questions come through at the moment. So what I'm going to do is, just to give people time to type some of these up, I'm going to leave you with one question that I would like you guys to have a go at, okay? So if you have something like 5x minus 5 is equal to 15. Have a go at solving that. I'll give you guys about 30 seconds. Okay, right, so you've got 5x minus 5 is equal to 15. Let's work through the steps that we've been through before to try and isolate that x. So I've got a minus 5 here. I want to get rid of it. So if I plus 5 on both sides, that will help me get a step closer to x is equal to something. So I've got 5x minus 5 and then plus 5 will help me get rid of that. Then I've got 15 plus 5, okay? Just to help you make that out a bit more easier. I've done enough of that, yeah? So I have 5x is equal to 20, okay? Now what times 5 gives us 20? You might automatically think, okay, it's 4. But if you were just to follow all the steps through, if we divide 5 on both sides, you're correct, you are right, I can see in the comments section, x is equal to 4. Now, when you've had a go at these questions and really gotten to grips with how all these rules interact with each other, the next level is to attempt word problems. And you would need essentially these rules just to help you, support you on those questions. If anybody would like any of these types of questions, just let me know. I can always send them over. Otherwise, I think now is probably a really good time to end the live. If anybody has any further questions they would like to ask me afterwards, I'll be around for about 10 minutes and I can just reply back in the comment section. Otherwise, thank you all for joining me today, and I just want to say another thank you to Saba, who runs this group, and the admin team for inviting me to provide this live today. If you have any other questions and you would like to contact me, then just head over to my Facebook page. It's Maths with Unmarked Potential. Thanks again, guys, and have a great week.